Yes, let's start with today's class. In the last class, we had learned about on threading also, how to do a threading operation on a lathe machine. Okay, so and I had given this diagram, right? So yes, so those who have not yet taken it up, take down this diagram. Okay, copy this diagram. So those who have already written the diagram, prepare the coordinates table. Copied the diagram. Over. Is it over?
Done, sir.
Done? Okay. Yeah. So yes, so here we have point number 1, sorry. Point number 1 over here, then 2, 3, 4, 5, then 6, and then we here have 7, 8, 9, and 10. Totally 10 points. Okay. So here the coordinates are, so first it begins with uh, it begins at a diameter of 15 mm. So x is going to be 15, z is going to be 0. Then second one is at the same height. So x is going to be 15. So this total length is 30. So z is minus 30. And then after that, for another 10 mm, we have grooving for a diameter of 10. Okay. So for 10 mm, we have grooving. So diameter over there will be 10 mm. Okay, and here it immediately drops down. So from point 2 to 3, point 3 drops down. So a z value will be same minus 30, right? Anyway, this is not is just for our information. Okay, and then point number 4. Point number 4, we have again 10 mm at minus 40. That is over here at this particular place. Anyway, this is also required only afterwards, not for rough turning or finished turning, right? And then we have point number 5, which will be here again at a diameter of 15 and at a distance of minus 40. And then we have the same diameter to be continued. So again, point number 5 will be x value will be 15 and z value will be up to minus 60 because 30 plus 10, 40, 40 plus another 20, that is up to here, minus 60. So when we do rough turning over here, we can directly start at this first point and end at point number 6, that is over here, whose x value is 15 and z value is minus 60 for turning operations. Right. Okay. And then we have a radius of 5 mm. So x value is going to be 25 and the z value is going to be minus 65 with radius 5 mm. Okay. So let's not forget this. And then we have point number 8. So it's a straight line. So 25 comma 80 minus 80 it is. And then point number 9, there's going to be a radius of 10 mm which they've given here, right? So horizontally it will be displaced by, it will be going in for another 10 mm and vertically also by 10 mm. So it is, yeah, right. And so it's going to be diameter of 45, that is x value, and z value is going to be minus 90 with radius 10. And finally, it's going to be a straight line of 45 mm diameter for another 20 mm distance. So 45 mm diameter, 90 plus another 20, 110 mm. Okay, right. So for this problem billet size, okay. So billet size, what we can take over here is diameter, let it be equal to I've taken here as 50, okay, 50 mm. Length, let it be equal to 120 mm, and Z will start at 2 mm. Yeah, Z will start at 2 mm. right? Okay. Now, what and all we have in this particular program? We have rough turning, finish turning, grooving, threading, and drilling. In the last class, we had seen all these operations except drilling. So, what is the drilling cycle code also? Let us see. Okay. So yes, so let's write the program. So first is the percentage symbol, then capital O, let it then followed by a 4-digit number. Okay, I have given the problem number itself as 05 comma 0505. Then N05, the first line of the program, G21, G98, and then we have next line G28 U0W0, send the tool to its home position. Then M06 T0101 for tool number 1, change of tool, and then start the spindle at 2000 rpm or 1500 rpm also we can give, and start the coolant also. Then the next line is going to be G00X51Z1. So we have taken the total dia to be 50. Okay, the raw material size diameter 50, length 120. So the tool will come at Z1 at the height of 51. So there will be a gap of 1 mm between the tool and the workpiece. So then G94 X minus 1 Z1 F at 0.2 is for the facing cycle. That so thereby 1 mm will be removed. Let us remove one more mm. So again the same code G94 X minus 1 Z0 F.2. Okay. Yes. And then we have G71 U.5 R1, which is for rough turning cycle syntax. Okay. And then the next line G71 P50, that is the starting line for the rough turning. Ending line ends as per the program that I have written ends for 75. Finishing allowance 0.1 and both X and Z direction with the feed rate of 0.3. Yeah. Yes, so the next line N50 G01. So we'll first give the first coordinate X15 Z0. Then from there it's going to be a straight line starting from the right hand side corner up to Z is equal to minus 60. Okay, for the same diameter. So thereby G01 X15 Z minus 60. And then there's going to be a circular interpolation for in the clockwise direction. So G02 diameter is going to be X25, radius and then the distance is going to be from 60 to 65, so minus 65, radius 5. And G01 it's going to be a straight line X25 Z minus 80. Then from there it's going to be an arc which is going to be in anti-clockwise direction. So G03 X45 diameter, final diameter after the curvature, and distance is going to be Z minus 90, radius are 10. Now we have G01, it's going to be a straight line X45 Z minus 10. Okay, and this is not required. It's not that, sorry. Yeah. Yes. And then finally stop the spindle, stop the coolant. So the turning is going to be, rough turning is going to be over. Usage of tool number 1. So send it to home position G28 U0W0. The next line, change the tool M06, insert tool number 2, which is for finish turning. And then start the spindle M03, S1000, sorry, 3000, M07, and then syntax for finish turning. So G70, P starting line P50, ending line P75, that is over here, and then feed is going to be 0.02. Yeah. Yes. Then after that, send back this finishing tool to its home position, stop the spindle, then change it to tool number 3, which will be for grooving. Okay. Which will be for a grooving tool. Yes. Any doubts still here? Any doubts? Yes. Anything? Okay. Right. Okay, so then of course I will give time for you to write down the program. Okay, so then we have the next line N120, start the spindle. So it's going to be grooving. So we'll have a slower rotation of the spindle S500. Start the coolant also G00X16 Z minus 30. That is, I want the tool to be placed over here. At this diameter is going to be 15. So tool will be at a height of 16. There will be a gap of 1 mm at a distance of minus 30. And the grooving should start at minus 30 and end at minus 40. So grooving tool syntax next, G75 R2 retract by 2. Okay, G75 again X minus 10, that is the after grooving the diameter, the smaller diameter that we need, until what distance? Minus 40. So this is going to be incremental distance in X and Z direction, which is in microns, 1000, P1000 and Q800, followed by R0. Without this R in this particular version of the software, it will give an syntax error. Okay, and the feed rate. Then finally, M05, M09 spindle stop coolant off, G28 U0 W0. So after grooving operation, then we are going for threading operation M06 T0404. Then start the spindle at 300 RPM. Okay, get the tool first outside the right hand end. That is, X is going to be 15, Z is going to be at 1. So it will be, the tool will be placed outside over here onto the right side. And now before we do this, we need to, before we go to the threading syntax, we have to do the threading calculation. So in a record book also, please write the calculation onto the blank side of the sheet, that is onto the left side. Okay, so thread height we have to calculate. So we'll assume that it is going to be an ISO thread. So what they are given, the pitch of the thread is 1.5 into 0.613 is what is the for the conversion for to find out the thread height. Okay, so we'll get 0.613 into 1.5, we'll get 0.9195 mm. And to calculate the minor diameter in the threaded portion, X is going to be the diameter minus 2 times pitch, that is diameter is 15, 2 times of the pitch value we got over here 0.9195 into 2 times. So 15 minus 2 into 0.9195. So we'll get around 13.616 mm. Right. So this calculation I also explained in the previous class. Okay. So now going to G76 threading cycle, number of passes P 3 passes, 15 and then 60 is the pull out angle, right? Q at 500 microns and at the feed rate of 0.01. And then again in the next line, G is 76, X where minor diameter value we have to put 13.616, sorry it is. Okay, and Z is going to be minus 30. Okay, or we can even give minus 31 also here. So what will happen is that threading we cannot stop exactly over here at the end of 30 mm. If at all we need, we can go out for another 1 mm. Anyway over here after 30 there's going to be a grooving. Already grooving is also being performed, so there will not be any problem. Yeah, and then followed by the pitch, sorry, the thread height. Okay, and again R value should be here. Q will give it as 400 and F 1.5. Okay, and here then stop the spindle and coolant, send it to home, send the tool to the home position, change the tool number 5, which will be for drilling operation. So now start the spindle M03, S is going to be 400. Okay, start the coolant, get the tool at the extreme right hand corner. We want it over here, just like this arrow mark that has been shown over here. So we want the tool which will be fixed to the tool holder, which will land in horizontally, right? So here the tool should first come from its home position to a coordinate where we need, here we need in this particular place, okay, we need it, that is X is going to be 0 and Z is going to be 1 or 2 mm. That means right side, there will be a gap between the right hand side end of the workpiece and the drilling tool tip. So thereby to get the tool horizontally exactly at the center, X is 0, Z 1 or 2 we can give. So next, the new portion is drilling cycle syntax. G74, okay, retract by 2 mm, that is R2, because we cannot drill continuously inside in one go. It has to move forward, come back again. So this retraction forward and backward motion of the tool is required. Then next line, G74, what is the X value? 0 till what depth? Depth of the hole is given over here for 15 mm. So up to 15 mm. So Z is going to be minus 15. Okay, and after how it should retract by 2 mm after what length it has drilled inside, after every 800 microns. Okay, and to go for this, the feed rate is going to be 0.2. Then stop the stop the spindle M05, get the tool back to its home position and end the program. Right? So yes, so okay, yes, any doubts till here?
No, sir.
Okay, so please copy down this program. Copy down the program. Let me put it on a new so that I hope it is entirely visible. Copy down the program, then we'll see the simulation. See, write these programs, what I've discussed in the class, because these programs are without any error. Programs that is there in the lab manual, some things are missing, like facing cycle is not there, and in some portions there is error. Okay, so thereby don't write that program in the lab record or even in your exam. We have given those programs so that you debug those errors and you get the right output. Copied the program. Is it over? Is it over?
Yes, sir.
Yes. Others? Okay. So let's see the simulation. Yeah. So for the same program, I've recorded the simulation. We'll go to CNC turn. Already the program was typed onto the notepad. So I'll go to open existing parts and select the file which was typed on notepad. Program gets loaded up. So the entire program here in the program editor space. So we'll save this program. Okay. And then we'll go to billet at the blank size. We'll give 110 or 120. And then diameter I've taken here as 50, raw material size diameter. Start Z at 2. So select the CNC machine. Then go for the tools that has to be assigned. So what are the tools that was assigned? I have deleting it first. So and use the new tools that has to be added up. Tool number 1, which is going to be for rough turning as well as for pacing PCLNL R8. Tool number 2 will be for finish turning PDJNL R.2. Then tool number 3 for grooving. We'll go to external groove. That grooving width 16 by 16 and depth of 8 mm. And left hand. So left hand means the grooving tool will be placed over here onto the left hand side. So right hand side will be onto the right hand end. So this is required only when we need so that when we do grooving operation, the tool and workpiece should not be damaged by other projections, the whatever is there. So thereby we need left and right. So maximum cutting depth is 8 over here, 8 mm. Then tool number 4 for threading, external thread. So 16 by 16, depth of 3 mm. So the tool will be like this. So maximum thread depth that we can give over here is for 3 mm. And then finally tool number 5, which is for drilling tool, the new portion that is over here. So we'll go to drill, twist drill, and in that go to the required diameter. They're given 8 mm is the diameter of the hole. So we'll select 8 mm twist drill from the given list, and we should also check this particular option. Okay, that is the grooves present onto the twist drill should be more than the depth of the hole that is required. So we have the flute length to be for 40 mm, right? Okay, and the length of the holder face for 90 mm, right? Diameter of the tool for 8 mm. So five operations, 5 tools. Right now, go for error check, save it, then check for any errors. No errors. So we'll fit the screen for simulation and run the program. First, as usual, for 2 mm facing. It's now going in for the finishing tool. Sorry, finish turning, then grooving. It starts at -40 and then goes back up to -30. And here is the threading portion. Here the thread, as usual, like how we used to do in the machine shop, the threading tool should start away from the workpiece, okay, and end a little bit outside the workpiece also. Yes, and then comes the drilling tool. So first it has to be here. There's a gap between the workpiece and the drilling tool, okay, and then it is going to be it's going to do its operation. Right? So it's going to retract by 2 mm every time after every 800 microns of drilling. Yes, so this is the simulation. So the program is correct for this particular given diagram. Yes, any doubts? Any doubts? Or you want me to repeat anything? Okay, so we'll go to the next problem. Okay, problem number 6. Copy down this diagram. I will copy it down. Is it over? So take the diameter over here in the grooving place over here as take it as 14. Yeah, 14. Yeah, have you all copied down the diagram? Is it over?
Yes, sir.
Yes. Okay. So yes, write the coordinates table. So what I'll do here is that I'll take coordinate number 1, 2 will be here, and because it's the same diameter initially for a diameter of 20, so point number 1 will be 20 comma 0, point number 2 will be here 20 comma minus 40 plus 10 plus 5, so 55, okay. And then point number 3 will be in the inclined, taper turning, so it is going to be 35 mm diameter, and length will be for another 10, so 65 minus 65, and then from there onwards till the end it's going to be the same diameter initially when we do rough turning. So point number 4, I'll take it as 35, and the length will be so from here another 25, so 65 plus 25, okay, so it's 90, right? So then we'll have over here as grooving 1, okay. So grooving 1 portion will be grooving 1 will start at I'll give it as 0.5. It starts at diameter. It's going to start here at this portion. So diameter will be 14 and at minus 40. So 14 is going to be diameter minus 40, and it will end at diameter of 14 and minus 50 for a distance of 10 mm, that is. Then grooving number 2 2 right, so point number 7, we'll have it over here at a diameter of 30, starting at 40 plus 10, 50, 60 and 70. So minus 70 starts at minus 70 Z value, and diameter is going to be 30. Point number 8 will be at 30, or the grooving distances for 10 mm. So here it will be minus 80. So we have 2 groovings over here that has to be done. Okay. So billet size, I'll take it as since the maximum diameter is 45, I'll take here as billet 50 mm, length 110 or 120 mm. I'll make it 110, and start Z at 2. Right. Okay, so let's go to the program. What a big program only. It's too small, so let it be. Okay, so yes, program number 6. So I'll start with percentage symbol and capital O followed by 4 digits 06, 06. First line G21, G98, sorry, G99. Then send the tool to its home position G28U0W0. Change the tool to tool and choose tool number 1 M06 T0101. And then start the spindle M03 at a speed of 1500 and start the coolant M07. Yes, so first we'll start with get the tool nearest to the nearest portion to the workpiece. So G00X, how much is the diameter that I've taken? Sorry, just a second. So it's 35, no, sorry. The billet size, let it be as, it's 35, and here I've taken 41. So let it be diameter be 40. Okay, billet dia 40. So let the tool come at and stop at a position of x is equal to 41 and z is 1. Then G94 facing cycle x minus 1 z1 at 0.2, and again G94 x minus 1 z0. So 2 mm of material will be removed by now. And then G71 for rough turning operation U.5 R1. So every pass is going to be 0.5 mm, retract by 1 mm. And G71 starting line for this turning cycle P50. As per my program, it ends at P65. Finishing allowance 0.1 in both x and z direction, U and W. And let the tool move at 0.3 feed rate. Okay. Then G01 as per the coordinates, G01 x20 z0. Then it's going to be a straight line. So G01 x20 up to minus 55. If I'm correct, yes. Okay. Then G01, it's going to be an inclined portion. So from 20 mm diameter, it's going to increase to 35 mm diameter, taper turning, and up to a distance of from minus 55 to minus 65. Then G01, again a straight line, same diameter, so x35, and up to distance of z is equal to minus 90. Then stop the spindle, coolant off, send the tool to its home position, U0, W0, yes, M06, tool change, finishing tool, start the spindle and let it go at around 2000 or 3000 RPM and coolant on. So G70, finish turning, P50, starting line for the cycle, turning cycle, ending and F.03. Then return the tool to its home position, stop the spindle and coolant, change the tool. Yes, so finish turning is over. Next is going to be grooving operation. So T03 for grooving, then start the spindle, spindle speed 500 for grooving operation, start the coolant also. Then G00, get the tool first nearer to the workpiece. Okay, so initially it will be at a diameter of 20 mm, right? We have to, from 20 mm diameter, we have to reduce it to 14 mm. So let the tool land here at 21 mm at a height of 21 mm. Okay, so that's why x21 z minus 40. Then grooving cycle syntax G75 R2, and then G75. The after grooving, the diameter should be 14 mm up to a distance of 50 mm. Okay, minus 50 microns in x. I mean the distance to be moved in x and z direction for grooving incremental 1800 microns, and R0 and F.2 the feed rate. Then G01. Okay, now comes the new portion. So here this is a new portion. What I have done over here, there are multiple ways to do this particular thing. What is this? Is that, see, after this tool has done, the grooving tool has done its job, one option is that if we have to change the tool, okay, for grooving, there's another grooving over here. One option is that we can send the tool to its home position and get it back to this grooving number 2. So we have to write the code to go back to its home position, then return back over here. That is one way. The other way is that if I'm going to use the same grooving tool in this grooving portion number 2 also, I can just, after the grooving is over in this particular place, I can take the tool directly to this new position, right? So I'll just show you 1 second. So once when I have it over here, So what I want over here is that initially I'll have the grooving tool over here, which will do its machining over here. So one option number one is that I can go from here to home position, then return this tool over here. So I have to write the tool, I have to write the code for this G28, U0, W0 and all. I have to write, and here when it comes over here, I should write G0, 0 and this particular coordinate value, X and Z value. This is option number one. What is the second option? The second option is that after finishing, I will directly take the tool to this position. Okay, so for that what I can do is that one way is that take the tool to this higher position, get it in this particular direction. So after finishing over here, this is G01 code. It has to be moved vertically upwards and then horizontally again in a linear manner. So again I will get over here as G01 and this particular value, right? So I have chosen the second method to do it because we are going to use the same tool again. Okay, but in the second method we have to be careful such that we have to give this point G01, okay, and this coordinate value x50 z minus 40. Okay, if we give directly anything else, either a lower value, if I just give x35 and what x35 and z minus 40 or something like that, there's every chance that it may hit this particular place. The grooving tool will damage here. Okay, because when it travels like this, there is every possibility that it can damage the workpiece. So we have to be careful while giving this particular coordinate when it moves over here. This is much safe. There's another option where I can directly write G00 and directly take it, but that is little bit I mean, there's always a problem that it can damage the workpiece over here, right? So I've taken the second way and written the program. So the next thing is that here for grooving number one, after grooving number one is over, I'm going to take the tool to a, see where is it stopped? It has stopped at x is equal to 14, z is equal to 50, and it would have been at a little bit higher portion. Now from there I'll take it linearly upwards, x is equal to 50, z is going to be minus 40. That means over here. I'm talking about this particular portion. I'm taking it vertically upwards. X is equal to 50, Z is equal to minus 40. Then after that, I'm going to write G01 once again, move the tool linearly. See, X is going to be 50 only, move it linearly in the horizontal direction. X is going to be changed from minus 40 to minus 70. So that means now the tool is going to move horizontally towards the left hand side from minus 40 to minus 70, and a tool will be placed here safely without damaging the workpiece. Okay, right? And then as usual the grooving cycle for grooving portion number 2. So G75 R2, G75 X30 is the minor diameter over there. Okay, then up to minus 80 because the grooving width is for 10 mm, right? So up to here we have 70 plus 10, 80 mm. So minus 80. So shifting of the tool increments in X and Z is 1000 microns and 800 microns and at a feed rate of 0.2. Then stop the spindle, coolant off, send the tool to its home position. Then change the tool to number 4, which is going to be threading tool. M03 S300, start the coolant. Get the tool, threading tool to little bit just outside the workpiece. Okay, that is the tool should land up over here. The threading tool should be here. Okay, right, at a height of 20, and Z is going to be 1. So Z is going to be 1. Okay, and then G76 P03, 15 degrees pull out angle, 60 degrees is the angle of the tool, Q500 R150. Okay, and that is in microns to be retracted. Okay, and G76X, we have to find out this. So for the threading calculations, 0.613 ISO thread pitch of the thread is going to be how much? 1.25. So 0.613 into 1.25, I am getting 0.766 mm. Okay, that's going to be 766 microns. And minor diameter to find the x value, to write the x value. So here it's going to be, I'm sorry, here how much have they given? It's 20, no? Yeah. It's going to be 20 minus 2 times the pitch, the height of the, sorry, minus 2 times the height of the thread. Okay, so it's 20 minus 2 into this 0.76, 2 times 0.6625. Okay, so I am getting 18.468 mm. So that is going to be the minor diameter of the thread. So this value and this value we need. So x is going to be 18.468 mm minor diameter up to z is equal to minus 41. I have just taken 1 mm so that the threading tool will reach up to here. And then yes, P766 in microns, that is, and Q400 R0 and F1.25, that is the feed rate. Then stop the spindle, send it to home position, change the tool for drilling tool, start the spindle once again, S400 coolant to be switched on, get the tool horizontally at x is equal to 0 and z is equal to 1, so that the drilling tool will land up over here. Okay, where x is 0 and z is 1. Then G74 drilling cycle, retract by 2 mm. Okay, and the syntax. So x is 0, threading depth is they're given 10 mm depth, so z is going to be minus 10, and incremental distance of 200 microns at 0.2. Finally, stop the spindle, return the tool back to its home position, end of the program, and this, right? So copy. Any doubts with this? Any doubts? Right. So okay. Yes. Please copy down this program. Yeah, I hope you all copy down this first three lines. Yes, as general one, G21, G99, G28, U0, W0. Then I'll just push it up so that the entire program is visible in one go. Yes, copy down the diagram fast. We'll see the simulation. Sorry, copy down the program. Yes. Copy down the program. Is it over? What guys, copied the program? Yes or no? What?
Yes, sir.
Yes. Okay, so let's see the simulation. Yes. Uh, Type the program first onto the notepad, save it, and then you can directly extract it from there with the program editor. So blank size, we're doing 110, length, diameter 40, Z at 2. Yeah, and yes, tools, I've already assigned the tools over here. Okay, so tool number 1 is for the PCLNL for rough turning, 0.8 radius of the tool tip. Okay, and then next one, that is the tool number 1 is for facing and rough turning. Second one, PDJNL R.2 for finish turning. Grooving, I've taken here, it's got the width of 2 mm, grooving tool. Okay, and then external thread, and then final twist thread having a 6 mm diameter of thread. Okay. So now say check for syntax, no errors. So adjust the screen for simulation and simulate the first facing for 2 mm. Meantime, yes, please answer your attendance also. Also call out your attendance. Yes, Niharika.
Present, sir.
Okay. Nihar. Nihar Venkat Sai.
Yes, sir.
Okay. Nikhil R.
Yes, sir.
Okay. Nilesh.
Present, sir.
Okay. Okay. Then Nirab.
Yes, sir.
Okay. Okay. So all of you, please see the screen now. Just a second.
Sir, Rohan, sir,
Grooving, for
59.
grooving, one grooving is going to get over. See, and just then the two. Yeah, 1 minute, 1 minute. Okay, so just look here, just see the screen. After the grooving is over here, I'm just directly taking the grooving to the grooving tool to the new place, which is going to read G01, line number N130 and line number N135 as per our program, and land up there to the new portion. And then the grooving cycle for the second grooving is going to start. Okay, right. Okay, Neerab is there. Prajwal R. Patel. Prajwal. Prajwal S. Bhatt.
Present, sir.
Okay, Prince Tagore.
Present, sir.
Okay, Rishabh Pandey.
Present, sir.
Okay, Rohan is there.
Present, sir.
Okay, Roshan.
Present, sir.
Okay, Suman Sagar.
Present, sir. And
Prajwal Patil is present, sir. He's texted on the chat.
Okay, yeah, thank you. Yes, Sagar GV. Sagar GV. Sanjay Raghav.
Present, sir.
Okay, Sharanya
Present, sir.
Hiramat. Who's that? Sagar GV, yeah?
Yes, sir.
Okay, Sharanya.
Yes, sir.
Sheikh Manan.
Yes, present, sir.
Okay. Shobit.
Present, sir.
Right. Then Siddharth B. Shankar.
So 48 present, sir.
48. Okay, fine. Okay. Shobit. Siddharth
Yes,
B.
sir.
Shankar.
Present.
Okay. Then Sagar Dutt Mathur. Sagar absent. Then Siddharth Sridhar.
Yes, sir.
All right. Subramanya.
Present, sir.
Sumuk.
Yes, sir.
Okay. Tirumana Shetty Rohan.
Yes, sir.
All right. Okay. Yeah. Okay. So, yes. So with this, we have completed the turning cycle. I mean, all the turning programs. And from the next class, we'll start with the milling program. Okay. Right. So all of you, please write your record. Okay. Just a minute. Uh, oh, it's that. Yeah. Okay, so manual, what you're supposed to write is the lab layout. Okay, that is on page number 9 over here. Okay, that let this lab layout be onto your left side of your page. Okay. Okay, there are too many things over here. Okay. Right, so all right, so I'll do one thing. Okay, introduction to the CNC programming. I'll send one copy in the group. Please write it according to that. Okay, and then what you do is program number 1, write the diagram, then the table, coordinates table onto the left side of the sheet, and below that you write the prepare a table indicating all the tools that is being used. Then onto the ruled side of the sheet, write the program. Okay, and then after that, on a new sheet, a new problem. Okay, let it be like that. Is that clear?
Yes, sir.
Yes. Okay, right. We'll stop here for today. Thank you.